Section 3.3 is on the properties of logarithms. The first one is called the product rule, and it says if you have a log of base b of an argument of m times n, that this is equal to the log of base b of m plus the log base b of n. So you're taking one logarithmic function and basically rewriting it as 2. So anytime you have the product, or anytime your argument is a product, you can split that apart into the sum of two different logarithms. Okay, for the examples, the directions say to use the properties of logarithms to expand the logarithmic expression as much as possible. And when possible, evaluate the expressions without using a calculator. Okay, so number one, we have log base 5 of 7 times 11. So if I have, again, a product, I can just rewrite that as the log base 5 of 7 plus log base 5 of 11. Okay, if you can reduce or simplify either one of these, then you would need to. Okay, but there's not an exponent I could raise 5 to that would equal 7, or that would equal 11. So these would not reduce. So all of this would be your answer. Okay, so if I look at number 2, log base 2 of 2 times x, first I would rewrite it as log base 2 of 2 plus log base 2 of x. Okay, I can reduce log base 2 of 2. Remember in the previous section, whenever the base of your logarithmic expression is equal to your argument, this just reduces to 1. So it's 1 plus the log base 2 of x. And then that's as far as you can go with it here. Okay, so this is the product rule. Taking a product, rewriting it as a sum. The second rule is called the quotient rule. And so the quotient rule says if you have log base b of m over n, so if you have a division or a fraction, that is equal to log base b of m minus log base b of n. So if it's a quotient, you could rewrite it as the difference of two logarithms. The numerator always being the one first, the denominator always being second. Okay, so same directions for example 3 and 4. So number 3, I have log base 5 of 7 over 13. So I could just write this as log base 5 of 7 minus log base 5 of 13. Okay, neither of those will reduce, so that's as far as we can go with it. Okay, if we look at number 4, these properties also apply to our natural log expressions. So I could rewrite this as the natural log of e to the third minus the natural log of 5. Okay, we learned in the previous section that I can reduce or evaluate if I have natural log of e, that those would just divide out, so that would give me, that would be equivalent to the exponent, which is 3, minus the natural log of 5. And then that's as far as we could go with it here. Okay, so this is the quotient rule. If you have a quotient, a logarithmic expression that has a quotient, you're going to rewrite it as a difference of two other logs.